right. So today, let's dive into something kind of mind-blowing.
Yeah.
Okay, so imagine
Okay.
having the power of like a large language model,
Yeah.
like ChatGPT, but like right on your device.
Right.
No internet needed, completely private. Sounds like kind of science fiction, right?
It does.
But it's becoming a reality.
Yeah.
And this is thanks to these things called LLM inference engines.
Yeah.
And you've sent us like a fascinating mix of sources on this. We have
Yeah.
articles comparing different engines, guides to like run them locally.
Right.
And we even have a research paper on running them right in your browser.
Yeah, that's right.
It's a lot to unpack. So where do we even begin?
Well, I think what's really striking is just how fast this field is moving. So we've got TensorArt, we've got VLLM, LM Deploy, MLC LLM.
Wow.
Each of these engines is like a specialist optimized for a different aspect of making these massive models run efficiently on different hardware.
So it's not as simple as just downloading a large language model and hitting go.
Right.
There's like a whole layer of technology underneath making it actually work.
Exactly. So to understand why these engines are so crucial,
Yeah.
you have to kind of grasp the sheer size of these LLMs. We're talking billions of parameters, which is like trying to fit the entire Library of Congress onto a flash drive.
Oh, wow.
They're very memory intensive and they're slow to run,
Okay.
especially since text generation happens like one word at a time.
Yeah.
Each word needs a separate round of processing.
Okay, so trying to run that on my phone while texting would be a bad time.
Precisely. And that's where these inference engines come in. They act as interpreters, helping these huge LLMs to run smoothly on all sorts of devices, from powerful servers down to your phone, your laptop.
Okay, that makes sense. So let's dig into some of these engines that we have here.
Sure.
We have this article comparing TensorArt, VLLM, LM Deploy, and MLC LLM.
Right.
What stood out to you in this comparison?
Well, it's like comparing race cars. Each has its strengths on different tracks.
Okay. So, for example, TensorArt really shines when you've got a powerful NVIDIA GPU. It uses these clever tricks like in-flight batching. Okay. Imagine an orchestra conductor who keeps all the sections playing seamlessly, minimizing any pauses. That's what TensorArt is doing.
So it's making sure your GPU is working at peak efficiency.
At peak efficiency.
Okay, so TensorArt is our high-performance speedster.
Yes.
What about VLLM? What's its specialty?
VLLM is all about throughput.
Okay.
So how much data it can process in a given time. Imagine a superhighway with traffic flowing smoothly and efficiently.
Yeah.
That's VLLM. And one of the ways it achieves this is through something called paged attention, which is a way to manage memory usage, especially when you're dealing with longer pieces of text.
Yeah.
So this is essential for tasks like summarizing lengthy documents or generating longer creative writing pieces.
So VLLM is like our efficient superhighway designed for those long-haul AI tasks.
Yeah, that's a good way to put it. Now we have LM Deploy.
Right.
What's its focus?
LM Deploy is the deployment wizard.
Oh.
It's all about making it super easy to set up and run an LLM, even across multiple machines. One of its key features is something called quantization, which is like creating a more compact version of the model.
So instead of having this like huge unwieldy file, quantization shrinks it down without losing too much detail.
Exactly. It's like taking a high-resolution image and compressing it to a smaller file size, but still retaining good quality. And LM Deploy excels at this, making it possible to run powerful models on less powerful hardware or even on multiple devices working together.
That's clever. So LM Deploy is all about making these powerful models accessible, even if you don't have the latest and greatest hardware.
Exactly.
What about MLC LLM? Where does it fit into this picture?
So MLC LLM is like the all-terrain vehicle of inference engines. It's built for portability, running on a wide range of hardware without sacrificing too much performance.
Oh.
This means you're not locked into a specific type of device or operating system, giving you more flexibility in how and where you use these LLMs.
I see. So we've got our speedster, our superhighway, our deployment wizard, and our all-terrain explorer. It's fascinating how each engine plays a different role in bringing these LLMs to life.
Absolutely.
Yeah.
And that speaks to the growing need for these powerful tools in various contexts. It's not just about running the latest chatbot.
Right.
It's about making LLMs work for specific tasks and environments, from scientific research to, creative writing on the go.
Okay, so let's shift gears a bit and talk about the advantages of running these LLMs locally
Okay.
on our own devices. Why would someone want to do that
Right.
instead of just using like a cloud-based
Well,
service?
that's where it gets really interesting. Running LLMs locally means your data stays on your device.
Good.
So, think about sensitive information like personal documents, financial records, proprietary business data. Do you really want to send that to a company's servers?
That's a good point. Privacy is becoming increasingly important.
Right.
Running an LLM locally would be like having your own like private AI assistant that
Yeah.
never shares your secrets.
Exactly. And with local LLMs, you gain control over customization.
Oh, okay.
You can tweak the model's parameters, adjust its behavior, even import models from places like Hugging Face. It's like having the source code to your own AI,
Wow.
allowing you to fine-tune it to your specific needs and preferences.
So I could potentially like train a model on
Yes.
my own writing style or
Mhm.
even my company's specific terminology.
Absolutely. You could tailor the model to generate text that sounds more like you
Oh, wow.
or better understands the nuances of your field. This level of personalization just isn't possible with most cloud-based services.
Right.
Yeah.
And let's not forget about like the benefit of offline access.
Right.
Imagine being able to use your LLM even if you don't have an internet connection.
Yeah.
Perfect for travel, remote areas, or just like peace of mind.
Knowing you're not reliant on somebody else's servers.
Yeah, that's a huge advantage for a lot of people. And it's worth addressing the common misconception
Okay.
that local LLMs are somehow less powerful
Oh,
than
God.
their cloud-based counterparts. That might have been true in the past,
Okay.
but the tools have evolved dramatically.
So you're telling me I could run a powerful LLM on my laptop without it turning into a space heater?
Exactly. Tools like llama.cpp and GPT-4 ALL have changed the game.
Okay.
They're designed specifically for local inference,
Okay.
and they perform remarkably well on consumer-grade hardware.
Okay, I'm starting to see the appeal. But are there any downsides, things our listeners should be aware of before diving into the world of local LLMs?
Well, one thing to consider is storage space.
Okay.
These models can be quite large,
Yeah.
taking up gigabytes of storage.
Right.
So if you're working with a device that has limited storage, it's something to keep in mind.
That makes sense. It's like downloading a massive video game.
You need to make sure you have room for it.
Exactly.
What about the setup process? Is it complicated to get these local LLMs up and running?
It's gotten much easier thanks to tools like LM Studio and Yan, but there's still a bit of a learning curve compared to just using a website.
Right. It's like the difference between ordering takeout and cooking a meal from scratch.
Yeah,
Both have their merits, but one requires a bit more effort up front.
a perfect analogy. And finally, it's important to remember that the AI landscape is constantly evolving.
Right.
New models are being released all the time,
Yeah.
and keeping your local LLMs updated can require some manual effort.
So it's like owning a smartphone. You need
Yeah.
to download those software updates to keep everything running smoothly.
Precisely. But despite those minor hurdles, the benefits of running LLMs locally are significant.
Yeah.
You reclaim your data privacy, personalize your AI experience, and truly explore the capabilities of this technology on your own terms.
It sounds incredibly empowering.
Right.
And speaking of empowerment, we have a whole ecosystem of tools and resources to help us navigate this world, right?
Absolutely. We've got user-friendly interfaces, command line tools, platforms for sharing custom models.
Yeah.
It's a real democratization of AI,
Okay.
putting the power of these models into the hands of individuals and smaller teams.
This is exciting. So we've talked about the why, the reasons to run LLMs locally.
Right.
Let's dive into the how. We have sources mentioning several tools for doing this.
Okay.
Where should we begin?
Let's start with LlamaFile, a project backed by Mozilla, the folks behind the Firefox browser.
Oh, okay.
What sets LlamaFile apart is its focus on creating self-contained executable files for these LLMs.
So no complicated installations or dependencies to worry about.
That's right. You download the file for the model you want, make it executable with a simple command,
Okay.
and then run it from your terminal.
Wow.
It's like having a portable AI engine that you can run anywhere.
Yeah. And portability is a big plus, especially if you're working across different devices.
Exactly. And LlamaFile supports a wide range of operating systems and hardware,
Oh, wow.
from Windows and Mac OS to Linux,
Yeah.
and even ARM processors. It's designed to make open source AI accessible to everyone,
Okay.
regardless of their technical expertise or the hardware they're using.
Okay. So I download the Llama file, I run it, then what? How do I actually interact with the LLM?
So LlamaFile usually sets up a local web server that you can access through your browser.
Oh,
It's like using a cloud-based service, but everything is running on your machine.
So I still get a familiar interface, but with the added benefits of privacy and offline access.
Exactly.
That's pretty neat.
And Llama even lets you convert models from other formats,
All right.
like the one used by LM Studio, into these executable files. So you can easily use models you've already downloaded or customized.
It's like having a universal adapter for LLMs.
Yeah.
So if I'm looking for a simple, portable, and efficient way to run LLMs locally, Llama seems like a great starting point.
I'd agree. But we shouldn't overlook the other tools we have here.
Yeah.
Each has its strengths. It appeals to different use cases.
Right. We also have GPT-4a LL,
Right.
which seems to be quite popular, especially among developers.
Yeah.
What makes it stand out?
So GPT-4 ALL is laser-focused on privacy and offline use.
Okay.
It has a user-friendly desktop application that lets you download, manage, and interact with various LLMs.
And it has an impressive library of models to choose from, right?
Yes. GPT-4 ALL gives you access to a wide range of open-source models, from the popular Llama family to more specialized ones like Mistral and Vicuna.
Wow.
You can browse and download them right within the application.
It's like an app store for AI.
Yeah.
But everything runs locally on your machine. I also understand GPT-4a LL supports local document processing.
Yeah.
Tell me more about that.
It's a powerful feature.
Okay.
You can feed your local documents, like PDFs or text files, directly to the LLM without sending them anywhere else. Imagine being able to analyze sensitive documents, get summaries, or ask questions about a large collection of files, all without worrying about data leaks.
That opens up so many possibilities.
Yeah.
Especially for people working with confidential information.
Exactly. And GPT-4 ALL even offers an enterprise edition for businesses looking to leverage local LLMs while maintaining strict security and compliance standards.
Okay, GPT-4a is ticking a lot of boxes.
Yeah.
User-friendly, privacy-focused, a rich model library.
Yes.
And powerful document processing capabilities. Anything else we should highlight about this tool?
One of its biggest assets is its large and active community.
Oh, nice.
There's a vibrant Discord server and a dedicated forum where users share tips, troubleshoot problems, and even collaborate on custom models.
That's a huge advantage.
Yeah.
It's like having a built-in support system for your AI journey.
And the community is constantly pushing the boundaries of what's possible with local LLMs. They're developing new features, optimizing performance, and even porting models to new hardware platforms. It's a testament to the power of open-source collaboration.
Speaking of open source, we can't forget Llama.cpp, which you mentioned earlier. This one seems to be more of a behind-the-scenes player, right?
That's right. Llama.cpp is kind of the engine under the hood for many local LLM tools, including Llama, which we'll get to in a minute. It's a C++ library optimized for running LLMs on various hardware, from CPUs to GPUs.
So it's like the engine that makes the car go.
Exactly.
But not something you directly interact with.
Exactly. And it's a remarkable piece of engineering known for its performance, efficiency, and broad hardware compatibility.
I'm curious, even though it's a command line tool, is it still relatively easy to use?
Yes. Once you have the Llama.cpp library and the model you want, you interact with the LLM using simple commands. It gives you a lot of control over the process, letting you adjust parameters, track performance, and even experiment with different quantization techniques.
So it's a powerful tool for developers and those who want to fine-tune the performance of their local LLMs.
Absolutely. And it's continuously being updated and improved by the open source community.
Oh, nice.
Ensuring it remains at the forefront of local LLM technology.
Okay, I'm getting a sense of the power and flexibility of Llama.cpp. Let's move on to Ollama, which you mentioned is built on top of this engine. What sets Ollama apart?
So Ollama is all about streamlining the experience of running LLMs locally. It has a simple command line interface that makes downloading, managing, and interacting with models incredibly easy.
So even someone who isn't a command line expert can still use Ollama effectively.
Absolutely. Its commands are intuitive and well documented. You can use them to download models from a curated library, create and manage your own local model repositories, and even customize the inference settings to suit your needs.
It's like having a personal assistant, but for managing your LLMs.
And Ollama emphasizes community integration. It supports a variety of third-party tools and applications, allowing you to expand its functionality and integrate it into your existing workflows.
That means I could potentially connect Ollama to my favorite code editor.
Yeah.
Or even use it to power a chatbot on my website.
Precisely. And it's under active development, with new features and integrations being added all the time.
It sounds like Llama strikes a great balance between ease of use and power, making it a solid choice for those who want a streamlined experience without sacrificing flexibility.
I'd agree. It's another example of how the open source community is driving innovation and accessibility in the world of local LLMs.
Okay, we've covered a lot of ground here. Llama-File, GPT-4a-L, llama.cpp, and Allama.
We have.
It's amazing to see the diversity and sophistication of options for running LLMs locally.
Yeah, it speaks to the rapid progress being made in AI and the increasing demand for privacy and control over our data.
And each tool has its unique strengths. Llama-File excels in portability, GPT-4a-L offers user-friendliness, and a vast model library.
Right.
Llama.cpp provides power and flexibility, and Allama combines ease of use with community integration.
It's like having a toolkit for local LLMs with each tool serving a specific purpose.
And as this toolkit expands and evolves, the possibilities for personalized and private AI become even more exciting.
I completely agree. It's a fascinating time to be exploring this technology.
And it feels like we're standing at the edge of something truly transformative.
Yeah, and one of the most exciting developments is the potential of in-browser LLMs, that web LLM project that we touched on earlier. Imagine accessing the power of these models directly in your browser. No downloads, no installations, just pure AI available anywhere you have an internet connection.
That's a powerful concept. It's like having a supercomputer in your pocket, accessible from any device with a web browser.
Exactly.
Yeah.
Think about the possibilities.
Yeah. It's personalized AI tutors that adapt to your learning style. Advanced writing assistants that can help you craft the perfect email or article, or even interactive storytelling experiences where the LLM is generating the narrative in real time based on your choices.
It's incredible.
It sounds almost too good to be true.
Yeah.
Are there any technical hurdles that we need to overcome before this becomes a reality?
Well, I mean, there are always challenges when you're pushing the boundaries of technology.
Right.
One key consideration for in-browser LLMs is performance.
Right.
While Web GPU and WebAssembly have made it possible to do some pretty amazing things within the browser, running large LLMs smoothly still requires careful optimization.
So it's like trying to stream a 4K movie on a slow internet connection. You need to make sure the technology can keep up.
Exactly. The team behind WebLLM is already working on this, using techniques like model quantization, kernel fusion.
Oh.
Imagine taking a complex machine and finding ways to streamline its parts, making it run more efficiently without sacrificing its power. That's essentially what they're doing.
So they're finding ways to make these LLMs leaner and meaner.
Exactly.
To the browser environment.
Precisely. And as browser technology continues to evolve, we can expect even greater efficiency and performance in the future.
That's reassuring.
Yeah.
Another concern that comes to mind is security.
Right.
Running LLMs within the browser raises questions about data privacy.
Sure.
And the potential for malicious code.
Yeah, that's a valid concern. But remember, web browsers are designed with security in mind.
Right.
They operate in a sandboxed environment, which helps isolate code and limit potential damage from malicious actors.
Okay.
It's also crucial to use trusted sources and be mindful of the permissions you grant, just like you would with any web application.
Right. It's like being cautious about the websites you visit, the files you download. Basic online safety practices still apply.
Absolutely. And the open source nature of projects like WebLLM allows for community scrutiny, meaning many eyes are looking for and addressing security vulnerabilities.
It's a collective effort to ensure the technology is safe and reliable.
Exactly. As in-browser LLMs become more common, security best practices and robust safeguards will become even more critical.
That's good to hear. So we've talked about the potential, the challenges, the security considerations. What about the real-world impact? How might in-browser LLMs change our everyday lives?
Well, the possibilities are vast. Think about education. Students could have access to personalized AI tutors that adapt to their learning styles and provide instant feedback.
Right.
In healthcare, patients could use interactive symptom checkers or virtual assistants that answer their health questions.
It's like having a team of experts available at your fingertips 24/7, right from your browser.
And for creative professionals, imagine writers using AI-powered tools to generate ideas, break through writer's block, or even collaborate with the LLM to co-create stories.
It's like having a brainstorming partner who never runs out of ideas.
And let's not forget about accessibility.
Right.
In-browser LLMs could make these advanced capabilities available to people who might not have access to powerful computers or specialized software. All they need is a device with a web browser.
It's like leveling the playing field, giving everyone a chance to experience and benefit from this technology.
Exactly. By harnessing the power of the web, we can democratize access to AI, empowering people from all walks of life.
I'm starting to see how in-browser LLMs could be a real game changer, not just for technology, but for society as a whole.
And we're just scratching the surface. As the technology matures and more people start using it, we can expect to see even more innovative and impactful applications emerge.
It's a truly exciting time to be witnessing this evolution. We've covered a lot of ground in this deep dive.
We have.
From the challenges of LLM inference to the rise of local LLMs and the potential of in-browser AI.
It's been quite a journey.
What's the one big takeaway our listeners should walk away with?
I think the key takeaway is this. The future of AI is becoming increasingly personal, private, and accessible. These tools and technologies are putting incredible power in the hands of individuals, allowing them to explore, experiment, and create in ways we could only dream of a few years ago.
And it's all happening so rapidly.
Yeah.
It feels like we're at the beginning of a technological revolution.
It really does.
And the most exciting part is that we're all participants in this revolution.
Right.
Whether you're a developer, a student, an artist,
or
simply curious about AI, there's a role for you to play.
Absolutely.
So to our listener, we say this: don't be afraid to dive in.
Yeah.
Explore these tools, experiment with them, and imagine how you might use them to enhance your life, your work, or even the world around you.
The future of AI is being shaped right now, and your imagination is the limit.
That's a perfect note to end on. Thanks for joining us on this deep dive, and we'll see you next time for another adventure into the world of knowledge and discovery.